Now that we have the Lewis dot structure of C2H2, let's evaluate the structure. The first question that we're asked is which element is the most electronegative? So we have two elements, carbon and hydrogen. When we look at our electronegativity values, we see that carbon has an electronegativity value of 2.5, and hydrogen has an electronegativity value of 2.1. The more electronegative atom has a partially negative charge. That means that because carbon has a 2.5, it is going to be partially negative, and hydrogen, because it has a lower electronegativity value, is going to be partially positive. So to answer the question, which element is most electronegative, and explain your reasoning, you would say carbon's electronegativity value is 2.5, hydrogen's electronegativity value is 2.1. Because carbon's electronegativity value is higher, carbon is more electronegative. The next question that we're asked is to use the differences in electronegativity to determine if the bond in the atom is either ionic, polar covalent, or nonpolar. So to answer this question, again, we need to look at our electronegativity values, but we're going to look at the differences in our electronegativity values. So if we say 2.5 minus 2.1, we get the number 0.4. So any difference in electronegativity between 0.4 and 1.8 tells us that our bond is going to be polar covalent. So our bond is polar covalent because the difference in electronegativity values is 0.4. The next thing that we want to do is we want to evaluate our Lewis dot structure so that we can draw our VSEPR structure. In order to evaluate our structure, we first have to figure out the number of atoms bonded to the central atom. And we have two central atoms in this case. So let's just look at this carbon. Attached to this carbon and this carbon only, we have two atoms bonded to our central atom. On this central atom carbon, we have 0 lone pairs of electrons. The way that we figure out our steric number or our group number is by adding those two numbers together. So we have 2 atoms bonded to the central atom plus 0 pairs of electrons gives us the number 2. When we look at our summary sheet, we try to find where we have 2 atoms and 0 lone pair electrons. 2 atoms and 0 lone pairs of electrons has an electron geometry called linear. The molecular geometry of 2 atoms and 0 lone pair electrons is also linear. The bond angle for 2 atoms and 0 pairs of electrons is 180 degrees. We want to be able to draw our VSEPR structure in 3 dimensions. So for a linear structure, all of the atoms are in a single line or are in a plane. And we can see our 2 hydrogens and our 2 carbons are all flat when we have a triple bond. So because they are all flat and they are 180 degrees away from each other or in a line, our Lewis dot structure and our VSEPR structure are going to look very similar to each other. For the purposes of this drawing, I've actually shown the 180 degree angle. The last thing that we need to do is to evaluate our Lewis dot structure to figure out if the molecule is polar or not, and also to determine our intermolecular forces. So when we look at our decision tree, the first question we're asked is, are there lone pair electrons on the central atom? And on this carbon, there are no lone pair electrons. The second question that we're asked is the substance a hydrocarbon? Meaning, is the substance made up of only hydrogen and carbon? And in this case, the answer is yes. Our substance is only made up of hydrogen and carbon. So our substance is a non-polar molecule. So explain your reasoning. It's a non-polar molecule because there are no lone pair electrons on the central atom, and the substance is a hydrocarbon. The next question is, what are the intermolecular forces? Well, because our substance is a non-polar molecule, that means that the only intermolecular force that we are going to have is a London dispersion force. Because we only have one intermolecular force, our London dispersion force is also the strongest intermolecular force in this compound.